Alrighty, so now let's go over more examples on chapter 8. So for the first example, we're given an arithmetic sequence, negative 26, negative 20, negative 14, negative 8, dot, dot, dot. We want to write an explicit formula for the nth term a sub n. So when I write an explicit formula in arithmetic, this tells me I want to use the general formula a sub n is equal to a sub 1 plus n minus 1 times d. Okay, since we want to find a sub n, okay, so this is what we want to find. But because we have a sub n, we also know that this is going to be unknown because this relates to a sub n. Right, so what do we need? We need a sub 1. We have a sub 1 right here, so we have that. However, what is d? Okay, so we can't plug in everything yet because we need to find what d is, but d is not too bad. It's just finding a sub n plus 1 minus a sub n, right? It doesn't matter, so I'm going to do a sub 2 minus a sub 1, so this is negative 20 minus negative 26. So this is going to be positive 6. Right, I'm checking it, and I notice, so my sequence is going up, so I know my d has to be positive. Right, so just, so you can either do those, or you could have also done a sub 3 minus a sub 2, or a sub 4 minus a sub 3. It doesn't matter. Just make sure they are consecutive. So now that we know everything, let's find our formula. So we have a sub n is equal to negative 26 plus n minus 1 times 6. Right, so this is negative 26 plus 6n minus 6. So this is going to be 6n minus 32. And this is the explicit formula for the nth term of n. So if I wanted to know any term, like if I wanted to know a sub 1,000, okay, we can just plug in that and then we'll find it with this. All right. Now let's do example 2. Example 2, we want to compute the sums below. So for a, we have 5 plus 1 plus negative 3 plus dot 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 plus negative 495. Right. When we computed the sums below before, it was under the arithmetic, or we found it when it was under the geometric. However, we're not explicitly told which one to use. Okay, so I have two options to find the sums. Okay, in order to do that, I need to determine, is this arithmetic or is this geometric? Okay, so if I look at this, oops, maybe a different color. If I look at this, okay, 1 minus 5 is negative 4, negative 3 minus 1 is negative 4. Okay, so my d is equal to negative 4. Since it has a common difference, then I know this is arithmetic. Right. If you just want to double check, if I do 1 divided by 5, I get 1/5. If I do negative 3 divided by 1, that's negative 3. Okay, it is not a common ratio, so it cannot be geometric. Since I know this is arithmetic, then I know to compute the sum, I'm going to have s sub n is equal to n divided by 2 a sub 1 plus a sub n. All right, so I look at this, right, and so I know a sub 1, this is equal to 5. My a sub n is equal to negative 495. But what is my n? Okay, we need to find the n. We need to know what term this negative 495 is. So, can't use it using my s sub n, so I'm going to use another formula I know. So we know a sub n is equal to a sub 1, oops, plus n minus 1 times d. A sub 1 is 5, we have n minus 1, and then d is negative 4, and we also know a sub n is negative 495. Okay, so this is going to be negative 500 is equal to negative 4 and minus 1. Negative 500 divided by negative 4, I think that's 125. Let me double check. Yeah, is equal to n minus 1. So what is n? N is equal to 126. Now that we know what n is, we can now find the sum. So s sub 126, this is equal to 126 divided by 2 times 5 plus negative 495. Okay. So 5 plus negative 495, that is going to be 490 times, and then 126 divided by 2 is 63. Okay, make sure this is negative. Okay, because a negative times a positive is a negative, so this is going to be negative 30,870. I also know that my sum is going to be negative because if you look at it, only 2 terms are positive. So that means everything else is going to be negative, so therefore my sum has to be negative. Okay. So now let's do B of part 2. We're given the summation, I is equal to 1 to 100, 3i. Okay. Just looking at this, okay, I know it's not a geometric because I'm not taking anything to a power. I'm just multiplying it, so my d is actually 3. Okay. If you're unsure, this is going to be 3 times 1 plus 3 times 2 plus dot 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 plus 3 times 100. So this is 3 plus 6 plus dot 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 plus 300. Okay, and the common difference is 3. You could actually, so I should probably find the third one so you can check 2 terms instead of just 1. So this would be 3 times 3. So this is 9 plus. So both of these have a difference of 3. All right. Normally it's really nice because once you know that this is arithmetic, then the other one's going to be arithmetic. At least just for these questions. But it's still good to recognize when it's arithmetic and when it's geometric. So, since I know this is arithmetic, I know I want s sub n is equal to n divided by 2, a sub 1 plus a sub n. All right, my n, I know my n is 100. My a sub 1, okay, we found that it was 3, and then my a sub n is equal to 300. Okay, I found it by plugging in values. So now let's compute it. So my s sub n is, we're going to find the sum of the 100th partial sum. So it's going to be 100 divided by 2. And then this is going to be 3 plus 300. Okay. So then 303 times 50, this is going to be 15,150. Okay, and that is the sum of this summation. Sorry, give me 1 second. Okay. Sorry about that, I just wanted to double check because I have something else on mine, but I don't see a mistake. So if you guys see one, let me know and I can give you an extra credit point. So let's do question 3. Okay, so the sequences below are either arithmetic or geometric. For each sequence, determine whether it is arithmetic or geometric and write the formula for the nth term, a sub n, of that sequence. So for A, we're given 14, 18, 22, dot, dot, dot. Okay. I do notice it's just like looking, you just add 4. But again, if you don't see that, okay, that's perfectly fine. We can just check our work. So if I take the difference of this is plus 4, and this is plus 4. So this will tell me this is arithmetic. But to double check our work, if I do 18 divided by 14, this is going to be 9 over 7. And 22 divided by 18, that's 11 over 9. Since so they do not have a common ratio. Therefore, it has to be arithmetic. Okay, so we know D is equal to 4. Okay, I can be more specific. So 18 minus 14, this is equal to 4. So now we want to write the formula. So I know the formula is going to be a sub n is equal to a sub 1 plus n minus 1 times d. When you want to find these formulas, I want to emphasize you do not want to use this. Okay, don't use it. The reason why is because if we want to start the sequence at a sub 1. Right? If you start it at something else, like you say like 12, then it's not going to be the whole sequence. Right? So, what is a sub 1? A sub 1 is 14 plus n minus 1 and then 4. It's 14 plus 4n minus 4. So what is my a sub n? It is going to be 4n minus 10. Okay. A good way to check is to see this is going to be plus 10. A good way to check to see, you can find a sub 1, that's 4 times 1 plus 10. This is equal to 14, so it matches our first one. A sub 2. Okay, so this is a good way to check to see if you have the correct nth term. Oops. Or general formula. So now let's do part B. So part B, I'm given 6, 12, 24, dot, dot, dot. Right? Okay. Again, I look at this, okay, and I do notice that it gets multiplied. However, because it gets big really fast. But just to double check, just to find the difference, so this is going to be plus 6, this is going to be plus 12. So we do not have a common difference. So now let's check to see if it's geometric. So 12 divided by 6, that is 2. And 24 divided by 2, or 24 divided by 12, that is also 2. So we do have a common ratio, so this is geometric with common ratio 2. Again, if you want it. So R could be 12 divided by 6. That's how I got 2. So since it's geometric, I know for my general formula, I'm going to use a sub n is equal to a sub 1 r to the n minus 1. A sub 1 is 6, my r is 2, and then I'm going to keep this as n minus 1. Right. We can keep it like this. I'm not sure what Alex wants exactly, but if you wanted to, you can actually expand this. So remember, so if I have 2 to the n minus 1, this is equal to 2 to the n divided by 2 to the first. Okay, so this 2 to the n, 2 to the first. So then this would be 3 times 2 to the n. Okay, this is just going even further. So I guess yeah, and this is the general. So one thing I actually want to talk about then is one of the examples we did in class. Okay, so just going back to example 9, okay, just in case. So we found that we had a geometric sequence 8, and then the general formula for the nth term was 20, and then negative 1/2 n minus 1. So if I wanted to go even further, this would be 20 times and then negative 1/2 to the n divided by negative 1/2 to the negative 1, or sorry, to the 1 plus 1. Okay. So on the side, so if I have 20 divided by negative 1/2, this is equal to 20 times negative 2 over 1, so this is going to be negative 40. Right. Again, if we want to check our work, if I have a sub 1, this is negative 40, negative 1/2 times to the first, so this is going to be 20, and then a sub 2, and so we know that's 20 because this was our a sub 1. Okay, I have negative 40, negative 1/2 squared. This is negative 40 times 1/4, which is negative 10. You can go back to your example 9, but 20 and 10, that's a sub 1 and a sub 2. Okay, so you can also write it like this. Okay, just depends on what Alex wants. Or you can go even further. All right. So now let's do the last example, which is computing the sums. Okay, so for A, I have 5 plus 5 1 to the 1/2 times 1/2 plus 5 and then 1/2 squared plus, I'm not going to write that, plus and then 5 to the 1/2 to the 6th. Okay. So I'm looking at this, and this has the form of a sub 1 r to the n minus 1. Okay, my a sub 1 was 5, and then my r, we have 1/2. Okay, so this is geometric. However, if we don't recognize that, that's totally fine. How would we do this? So what is this? This is also going to be 5, and then plus 5 over 2, plus 5 over 4, plus dot dot dot. Okay, and then if I took, even if I took the difference, 5/2, so if I try to find d, 5/2 minus 5, this is going to be negative 2.5. I'll call this d1. And then d2 would be 5/4 minus 5/2. Okay, this is 5/4 minus 10/2. This is going to be negative, 10/4. This would be negative 5/4. Okay, not the same. So I guess to be more clear, this would be negative 5 over 2. Okay, they're not the same. So therefore I know it's not arithmetic. So if we try to find the ratio, this is going to be 5/2 divided by 5. This is 5/2 times 1/5, which is 1/2. If I find r sub 2, this is going to be 5/4 divided by 5/2. This is equal to 5/4 times 2/5. This is equal to 2/4, which is equal to 1/2. Okay, they're both the same. They don't equal. Okay, since this is the same, what does this tell me? This is geometric. Right, so I know I'm going to find the sum of a geometric sequence. So I know this is going to be S sub n is equal to a sub 1 times 1 minus r to the n over 1 minus r. Okay, so what do we need? We have a sub 1, okay, and we want to find r, and we want to find n. So a sub 1 is 5. My r is 1/2, and my n is 6. Okay, I got the 6 from right here. So my s sub 6 is equal to 5 times, and then 1 minus 1/2 to the 6th, all over 1 minus 1/2. I'll let you guys put that in a calculator yourselves. Okay, but you should get maybe I'll solve it. Okay, so this is going to be 5 times, and then this is going to be 1 over 64 all over 1/2. So this is going to be 5. And then this is going to be 63 over 64 all over 1 times 2 over 1. So this is going to be 10, 63 over 64. So this is going to be 630 over 64. But we can divide the numerator and denominator by 2. And so you will get 315 over 32. Okay, and that's the sum. Now for part B, okay, we're given the summation k is equal to 1 to 8, and then we have -3 to the k. All right, so since we're taking it to a power, I know it cannot be a arithmetic because, yeah, you're taking it to a power. So this is geometric, so I know I'm still going to use s sub n is equal to a sub 1, 1 minus r to the n over 1 minus r. So, my r, so it's pretty much like what you're multiplying. So remember, it's a sub 1 times r, a sub 1 r squared, a sub 1 r cubed, dot, dot, dot. So pretty much the common ratio is what we are taking the power to. So this is -3. I've showed you guys multiple times how to find the common ratio, so I'll let you, if you don't believe me, I'll let you find it yourself. My n is 8 because of this one. Okay, and my a sub 1, okay, I don't know what that is, so I need to compute it. So, or you can even just use this. So a sub 1 is going to be -3 to the first, which is just -3. So what is my sum? My sum, s sub 8, is equal to, and this is -3. 1 minus -3 to the 8 all over 1 minus -1 minus -3. So this is -3 times, this is going to be 4. So 3 to the 8th is that. And I know this is going to be positive because a negative to a positive power is positive. So 1 minus all of that, this is going to be -6,560. When I reduce that, so let me subtract it by 1. And divided it by 4. So then I get -3 and then 1,640. So this is negative. So this is going to be positive 4,920. Right, and that's the summation. So one thing I want to make a comment on before we call it a day is talking about ratios. So I just want to say, so if you have a ratio and it's greater than 1, okay, then we're going to have we should have a big number for, or a whole number for our sum. I guess it might not always happen, but I'm just saying like pretty much a huge number. Like if you look at this 4,920, when my r is -3, that's significantly bigger than when our r was 1/2. Okay, because it was just a fraction. Okay, or if we have this scenario. Okay, so why am I mentioning it? Just because when we have sequences, so I just want to let you know. So if the absolute value of our common ratio is greater than 1, then our sequence is going to get bigger and bigger. Like each term is going to get bigger. Okay, and then for if it's between 0 and 1, remember the absolute value. So what does it mean? If it's negative, it just means that it's going to alternate. Okay, but if it's bigger than 1, it's going to get bigger. And if it's a fraction, like for example 9, remember our common ratio was negative 1/2. So the absolute value of r was equal to 1/2. And as you can see, the sequences, the terms got smaller and smaller. Okay, so that's a good way to check it. So if the sequence decreases, then your ratio should be a fraction. If it's increasing, then your ratio should be a whole number. Right. So that is it for new material. Don't forget we have a test on Friday. And if you have any questions at all, feel free to reach out. And hopefully I can help to the best of my ability. So you guys all have a nice break. Good luck on your test, and I will see you all Monday the 30th. Bye.